Hello, and welcome to my Python course. My name is Ties de Kok, and I am an assistant professor in accounting at the University of Washington. This is part one of a multi-part series where I will walk you through a couple of theoretical concepts that relate to using Python for research. This course will consist of 5 main components. The first component, which I will discuss in this video, is what is Python? How can we use Python? And I'll tell you a little bit about the basic syntax of programming in the Python language. The second video will be about how can we deal with data. More specifically, how can we use pandas in order to manipulate data and perform other operations on data sets and data frames. In the third recording, we will go over the concept of gathering data from the web scraping, if you will. Then in the fourth recording, we will focus on how can we deal with textual data, and we'll go into natural language processing with Python. And then finally, in the last recording, I will go over a collection of miscellaneous topics, more specifically version control, how can you potentially speed up your code by using multiprocessing, and a couple of other best practices that I've encountered in my research. Now, what are the basic principles of this course? Learning Python can take some time. Learning anything takes some time, in particular if it's a programming language. For some of us, it comes a little easier. For some of us, it takes a little bit more time. But generally speaking, I will follow 2 main principles, which is 1, I cannot inject you with Python knowledge. Just watching these videos is not going to make you proficient with Python to the extent that you can immediately apply it to your research. It's up to you to ultimately practice using Python in order to gain that proficiency and to get to that proficiency level that is required in order to conduct research using Python. Now, in order to facilitate this, I have one main goal in mind, which is for me to make it easier for you to learn yourself Python. And the way that we will do that is by, on the one hand, me providing you theoretical concepts through these videos, but also by providing you problem sets that you can try to solve in order to really get some mileage under your belt when it comes to programming in Python. So how are these different components, how are these classes structured? So we generally speaking have 5 classes, of which the first 4 are the core elements of this class. And each of these will consist of 3 main elements. There's going to be a lecture recording, such as this one. There's going to be a demonstration, and in this demonstration video, I will go over showing you how I go about doing some code so you actually can see me do it, because generally that can be very insightful. And then finally, there is the hands-on component, which are the hands-on problems, which are Jupyter notebooks that provide you with problems that you can try to solve. You do not have the answers for these up front, but you will be provided the answers at the end of this course. All of these slides are also provided on the accompanying Github repository. And there's 2 main Github repositories that I've created over time that contain reference material when it comes to using Python for research. And both of these are linked in this slide, and you can also find them on my GitHub page. They're called Learn Python for Research and Natural Language Processing with Python. For those of you that are following this course for credit, be aware that there is a deliverable, and that deliverable is that all these different problem notebooks, I expect you to complete these and hand them in to me by a specific deadline. If you're following this course as part of the Limburg program, in particular for 2020, then that deadline is going to be June 29th, 2020. There's 2 small remarks here with regards to this deliverable, which is 1, there is a third part to each of these problem notebooks that I call Ties, I am bored, please give me a challenge. Those parts are just difficult questions. If you really want to get a challenge, those ones you do not need to fill out in order to gain credit for the deliverable. And finally, you'll be able to complete most of these problems during the course. So you don't have to do this on your own time necessarily. You can all do that while you're taking this course. So what is on the agenda for today? We'll go over 5 main parts first, which is why Python? Why should we go over Python versus any other language? What is the Python ecosystem? How can we use Python? What are Jupyter notebooks and what is this whole Jupyter thing? And finally, I will tell you a little bit about the Python syntax. Now, why would you go for Python? And generally speaking, I would say that it really doesn't matter all that much which programming language you will go for, as long as it can serve one main purpose, which is it helps you to get to wherever you want to be. And it does so in a way that saves you the most amount of time. Python, I think, is a programming language that is particularly suitable for this purpose. And this is also reflected if you look at just the trends of programmers, and this is taken from a 2018 kind of prediction on Stack Overflow, where it will show you that Python has seen kind of a tremendous increase in popularity over the years, and it's only projected to increase. And one of the primary reasons is that Python as a language is one, very versatile. You can use it for a lot of different things, not only data science, but also just straight up programming, or even stuff like robotics or whatever you want to do with it. And second of all, one of the core principles of the Python programming language is that it is intended to save the programmer as much time as possible. And it does that by trying to provide a syntax that is somewhat easy to read and somewhat easy to understand. And it comes at the cost of maybe slightly slower runtimes. But for our intents and purposes, those slightly slower runtimes are barely going to be noticeable. So generally speaking, the amount of time that we save is primarily what we care about. Now, another thing that illustrates the relative ease of use of the Python programming language is Stack Overflow, which is a popular Q&A platform for programming questions, among others, yearly does a survey. They call this their annual developer survey. And one of the things they ask is, what are the programming languages or software that you really like to use, that you really dread using, and that you would like to learn how to use? And two things that are worth pointing out here is that Python is second on the list when it comes to loved programming languages. That's just because it's so relatively easy and painless to use compared to other programming languages. And it's also the most wanted. And that is obviously correlated because the more people use it, the more people would like to use it because there's more support, there's more need. But ultimately, that shows you that there's this upward trend of people that really like using Python, either for research purposes or for programming purposes. And there's a lot of people that try to learn it. So there's a lot of material available. A common competitor, quote unquote, when it comes to using Python as a programming language for research will be the R language. And R has a lot of benefits, and I'm definitely not discouraging you from using R. But if you're kind of on that crossroads where you think, well, should I be using Python, or should I start learning Python, or should I start learning R for research? I would generally recommend you to go with Python if you want the path of least resistance. Because generally speaking, I think Python is one, a little bit more versatile, and second of all, it's a little bit more of a pleasant language to use. And you can tell here that if you look at the most dreaded languages, then Python is not in that list, but R is, I think, number 8. So that just puts that into perspective. If all you're doing is really statistical modeling, then I would say stay away from Python and then kind of pick up R, because R really shines in that field. But more generally, as a general programming language that you can use to solve a wide variety of problems, Python is very hard to beat. Now, one common thing that you might encounter, and it's getting less and less of a problem, which is good, is the fact that there is a little bit of a version gap. You have Python 2 and you have Python 3. And at some point, the developers of Python decided that there was a couple common flaws in Python 2 that they would like to solve for the future. And they decided to do that by introducing Python 3. Python 3 is a better programming language. It's a better version compared to Python 2, essentially all across the board. It implements a lot of very good improvements, but it does do one thing that can make your life relatively difficult, which is it created some incompatibilities between running Python 2 code and running Python 3 code. A good example of this, and this is the primary area that you might encounter, is the print statement. Because in Python 2.7, a print statement does not require you to put the brackets around it. You can just do print, space, and then whatever you want to print. In Python 3, that is no longer supported because they started treating the print statement as a function, just like any other function call. So what they do is you now have to wrap your string that you would like to print, you have to wrap that in parentheses. So in that case, if you were to have that first, the old syntax, and you would then try to run that in Python 3, it will throw an error. So you cannot just take your Python 2 code, dump it into Python 3, and expect everything to work flawlessly. you're going to have a couple of these minor incompatibilities that might kind of create a bit of a headache. Now, my recommendation is, and this is a relatively easy recommendation in 2020, is if you don't have to use Python 2.7 for a very specific reason, just pretend Python 2 does not exist. When you think about Python, just think about Python 3. Most notably, we will be using Python 3.7 because that is the Anaconda version that is available at this point in time. But know that any version, Python 3.6 plus, is usable for all of the materials that I'm providing. So the rule of thumb, always start with Python 3, and only if you really have to, you can always install a second setup of Python 2, and then you can run whatever code you need to run in that separate environment. So the Python ecosystem. Now, one of the most powerful elements of the Python programming language is the fact that you have the Python language, which is kind of the core backbone of the programming language, but you also have an enormous amount of either built-in or third-party packages and libraries that you can install into your Python environment. And these additional packages and libraries extend the functionality, the built-in functionality that you can use whenever you use Python. And this is amazing, because what it allows you to do is you need to do something, you want to calculate some metric or you want to deal with some data format, then all you would have to do, or generally speaking what you would do first, is you would go into Google and you search Python, whatever problem you're trying to solve. And because it's such a widely applicable and widely used programming language, the likelihood that you're going to bump into a package or a GitHub repository or a website that describes how you can do this in a very easy way, because someone has already created a package for it, is extremely large. And this can save you a lot of time versus having to program everything from scratch. So the way that this works is whenever you start up Python, in one of the multiple ways that I'll show you in a moment, the Python code that you have at your disposal is relatively limited, because Python goes by the philosophy that it will load in just the bare minimum, and then you can tell Python what functionality you would like to use for that piece of code. You do this via import statements. So an import statement is a way of telling Python that, hey, I want to run some code and I would like to have all this functionality in order to execute this code. And this keeps it so that you don't need to load everything in memory anytime you open up Python, and you just load in what you need. So you're going to have a lot of import statements at the beginning of your code, generally speaking. Now, there's two types of packages. There are those packages that come with any Python installation. This is, for example, the math library. So the math library, you can do import math. That will import the math library, and you have a bunch of common math operations that you can then do using that code. And the second type are third-party packages. And these are these third-party packages that you can find on the internet. So these third-party packages you can find on the internet, and then you can install them into your Python environment in a variety of ways, which I'll show you in the next slide. And both of these, they behave very similarly once you've imported them, but the built-in ones you don't have to install, the third-party ones you do. So how can you install these third-party packages? Let's say you have a problem, you go into Google, you find a package that you would like to use. How can you get that into your Python setup? Now, there is a couple of different ways, but generally speaking, I would recommend you to use one of two. The first one is to use a command called pip, and the second one is a command called conda. And these don't necessarily come pre-installed with Python, but the way that we will be setting up our Python setup will have both of these commands set up, so you can just use them. So the pip command will allow you to install packages that are located on the website that is called the Python Package Index. And it's just a website where you can open up a particular package. And what it does is it connects to that pip command, and you can say, well, hey, I have this package that I would like to install. And then you type pip install, the name of that package that you find on the Python Package Index website, and then it will try to automatically install that for you. An alternative version that can sometimes solve some problems that you might experience with pip is you can also use an alternative version that comes with the Anaconda distribution, which is the conda command. And the conda command works just like the pip one, it just pulls up packages from a different source. If you just started out using Python, your inclination might be you go to python.org, the website, you click on download Python, you're like, well, I would like to have Python 3.7 or 3.8 or whatever. You go there, you download it, you install it, and then you're like, well, I'm good to go. I would generally not recommend to go that route. in particular if you intend to use Python for research purposes. And the reason for this is that the bare Python installation does not come with any third-party packages installed. And whenever you want to use Python for research purposes, you are going to need a wide variety of third-party packages in order to make your life as easy as possible. And this list can be very long. You could say, well, maybe you need 30 different packages. If you were to start with the default Python installation that you get from python.org, you would then have to go down the list and type pip install or conda install for any of these packages that you would like to install. Then maybe you don't do them in the right order, or there's version incompatibilities and everything starts breaking. So that's a huge headache. Alternative, which is fortunately available to us, is to use a prepackaged distribution. And a prepackaged distribution essentially is just a Python installation that already comes pre-installed with a wide variety of packages. The one that is most useful for data science or research purposes is the Anaconda distribution. And the Anaconda distribution, I have the link provided here, but the Anaconda distribution comes prepackaged, bundled with a very large amount, I believe over 100 packages that are generally useful if you were to use Python for data science or research. So let's say that we've followed all the steps and I have separate videos on how to set up Anaconda, how to set up the Anaconda environment. I will provide links to all of these in the description. So you can set all of that up using those videos. But let's say that we've completed all of this, we've done some tests, and we now know that we have a working Python Anaconda installation. How can we now run code? Now you can run code in a wide variety of different ways, but I'm going to show you 3 main ways. The first one would be for you to save your Python code in a Python file, and a Python file is indicated by the .py file extension. You would put all your code there, and then you would go into your command line or terminal window, and you would type Python, and then the name of your Python file. Now what this will do is it will then execute all the code that's in that Python file, and then as soon as it's done, it will close everything back down. Now a downside of this approach is that anytime you want to make a change, or you want to inspect part of your code, what you would have to do is you would have to open up your text editor, you would have to change that line of code, you would have to save that file, you would have to go into your terminal window, and you would have to rerun that code and then just see whether it works. This is not very interactive, and it can actually be pretty difficult to use. So an alternative way would be to use an interactive Python kernel. And an interactive kernel will allow you to write code, see the input as it gets calculated or as it gets executed, and then you can immediately execute another line of code without the entire Python kernel closing down again, like if you were to have a Python file. A common way for this to do this would be you open up your command line or your terminal window, and then you would type either Python or IPython, and that will open up a little window where you can execute Python commands. Now this is interactive, so that's a plus, but it does have one major problem, which is you obviously want to save your code. You don't want to just work in this, get the file that you want, and then all your code being gone. That's not ideal. So that's where we end up with the method that we will be using. And this method uses what we call Jupyter. And Jupyter is an ecosystem in itself, and it comes with 2 main components, Jupyter Labs, which is best thought of as a kind of a code editor that comes with a bunch of features. And then we're going to use Jupyter Notebooks, which are a file type that you can run within Jupyter Labs or as a standalone setup that will allow you to interactively run code, which means that you can execute code and then see what happens and then execute another command without the Python kernel closing. But at the same time, it provides you a file that you can actually save. And it provides you a whole bunch of extra functionality as well. Most notably, you can print graphs, you can add kind of markdown rich formatting to your documents, and generally it's just a very pleasant way of interacting with Python code. One worth noting, Jupyter is not specific to Python. It was originally developed as a Python tool, but currently it's language agnostic, and you can use it with a wide variety of different software and programming languages. It will look something like this. I have a separate demonstration video that I encourage you to watch in order to go over how the Jupyter Lab works, how you can open up Jupyter Labs, and the same thing goes for the notebooks. But just so that we're all on the same page, I do have a brief illustration here, a little animation that will show you how it will roughly look like when you're working in a Jupyter Notebook. You will generally open up the Jupyter Notebook in a browser, And then you would have a bunch of cells, and you can put code in these cells and you can execute the cells. And anytime you execute any code that's in a cell, the output will appear right below that particular cell. And you can also include titles or equations or images or whatever you want, as is currently being illustrated in the animation. Now, I will not spend too much time on this, but just so you don't get confused about how a Jupyter Notebook or a Jupyter Lab server works, is that you don't need to have a remote server or an internet connection, for that matter, in order to use Jupyter Labs or Jupyter Notebooks. You can run a Jupyter server locally on your computer, and I have a video that will show you how you can open that up. And then your browser will just locally connect to that local Jupyter server, so you do not require an internet connection for that to work. None of your code is being shared with third parties. It's all contained to your local system. Jupyter Notebooks, I have a cheat sheet here with commands. I go over this in that separate video as well. Now, the thing that remains is the Python syntax. And frankly, I am actually not going to spend too much time talking about the Python syntax because I believe it to be relatively straightforward. And a good example would be this piece of Python code right here. As you can see, even without knowing any Python code, without knowing how the Python syntax works, you should be able to understand what this code is doing. Most notably, we'll have a bunch of numbers. We call that a list, and that's assigned to a variable called numbers. We have a response, which is a string, which is just a piece of text. And then what we do is we're going to have a loop where we say for I in numbers, so for every element in numbers, which is a list. And then we have an if statement that says if that number is above 10, then you should print the response and you should print the number. So this is kind of the core essence of how Python would work. It's intended to be read almost like the English language, which works for a simple example, but as soon as you start making a more complicated piece of code, that kind of becomes a little bit more difficult to see. But generally speaking, you can go through a piece of code, and the idea would be that even someone that has no idea about how the Python syntax works, they should still be able to get, with a little bit of effort, a pretty good understanding of what the code is actually doing. I will have a separate reference notebook that will show you all the common operations that you can do in Python. So I'll recommend, and that's all linked on the Github repository, I recommend you to go through that file just so that you have a basic understanding of how these operations would work. There's three kind of caveats that I would like to discuss before you start going into actually trying to run some Python code. And the reason that I put these here is because knowing these things from the very beginning can save you some headaches later on. Which is the first one is that you can put your import statements where you import your packages, either built-in or third-party. You can put them anywhere in your document. But I would strongly encourage you to always put all of these imports at the very beginning of your code file. And the reason for this is that whenever you share your code with someone else, they need to make sure that they have all of these packages installed as well if they would like to execute that code on their machine. If these import statements are all over the file, they will have to go through the entire file to just figure out what packages you used. If you put all your import statements at the very beginning, it's obvious when someone were to see your code that these are the packages that you need to have installed in order to run this particular piece of code. So just start with your import statements. And the second thing is, if you've ever done any other programming, such as JavaScript or C++ or whatever, you might not be familiar with one of the core kind of design decisions of the Python language, which is the fact that the way that Python code creates scope, the way that it knows what to execute within a loop, for example, is based on tabs. So based on the white spaces that you will see in the code. So in this case, if we look at that example that I just showed you, you can see that there's different indentations. We have our for I in numbers, which is all the way to the left. Then we have one indentation for if, blah, blah, blah. And then we'll have another indentation with the print statements. These indentations are not just for looks. These indentations are actually part of the code, and you need to make sure that this works, because otherwise you will kind of break up the scope and things will not happen as they should be. Because, for example, here, the reason that I need to have two tabs for these print statements is because I want to limit print response and print I only to be if the if statement holds, which is if I is larger than 10. So if I were to put those all on the same line, then it will not understand what to run if the condition is true, and it also does not know what to run in the iteration or for each iteration in the loop. And finally, And this is something that I also struggle with sometimes, but it's one of those things where you're going to do this wrong at some point and then you wish you followed this advice, which is that whenever you do a try except statement, and a try except statement is a statement that you can use in order to catch errors, is you can just do try except, and we call that a blind try except statement. Then it's just going to catch any error that is thrown by your Python interpreter, and it's just going to continue your code. This can be what you want, but sometimes you have these try except blocks and you don't specify the specific error that you would like to catch. You run your code and then you just go about your day, you run your analysis, you publish your paper. But it might be that you are actually having some other errors that you were not aware of, and they never came to your attention because you had this blind try except statement. So generally speaking, it's best to have specific errors that you would like to catch instead of just catching any errors. And you can do that as provided in this example. And that will make sure that only for that specific error, it will be ignored, but any other error will still be brought to your attention and you can resolve them just to make sure that everything happens as it should be happening. So what is next? Depending on the setup that you're currently following, I would recommend that first you make sure that you have a appropriate Python setup set up. The instructions for this are provided on the GitHub page, and there's also videos to help you guide you through these different steps. Then I recommend you to watch the accompanying demonstration video. The links to these is also provided on the GitHub page. And then once you've watched that, then you should be equipped with your basic amount of knowledge, and then you can move into your problems. Now, depending on the setup you follow, there might be a group component to this. Generally, I recommend you to do part 1 with the group before any Q&A sessions, and then do part 2 during the live sessions. If you're following this asynchronously offline, then you can just work through the material on your own pace.